everybody. So in today's video, we're going to be going through a portion of task 7.3, and we're going to just be talking today about naming and drawing pictures related to rays and angles. So let's start with defining a ray. Just like we've been doing for the last few days in class, a ray is a new geometric shape that we're going to be learning about. So a ray is a half line that has one endpoint and that goes on forever in one direction. So I'm going to go ahead and draw a ray here. A ray is going to start with an endpoint and go on forever in one direction. When you see a ray, you're often going to see a ray with several points on it. Now you'll notice that on the side of the ray that goes on forever, I've drawn a little arrow. So you can think about this as half of a line. If you kind of took this ray and you flipped it around and made it go this way too, it would be a whole line. This is just half of a line. I'm going to go ahead and give these points some names, A, M, and V, and that way we can talk about how to name a ray. So there is one way to name a ray, and there are a couple rules. When you name a ray, the first rule is you always use 2 points. So you're never going to use 3 points, you're never going to use 4 points, and you're never going to use 1 point. You always need 2 points to name a ray. Those have to be 2 very specially chosen points, though. The first point in the name of a ray must be the endpoint. Now, in this case, the endpoint of this ray is point A. So I know that the name of this ray is going to have to start with the letter A, and then I can choose any of the other points on the ray. So here's an example of how I could name this ray. I could name this ray, start with A, because that's the endpoint, and then I could say, let's say it goes in the direction of M, I'm going to put a little M here. Now, just like when we named a line, we drew a little picture of a line over the top. When we named a segment, we drew a little picture of a segment. When we name a ray, we're going to draw a little ray over the top. Now, another option here could be that I could name this ray A. I still have to start with A because that's the endpoint, but then I could use the point V because this ray also goes in the direction of the point V. Now, again, I need to draw the little ray over the top to say that this is a ray that I'm naming. It's not a segment, it's not a line, it's a ray that I'm naming. The common mistake, the number one most common mistake that I see here is that students do not start with the endpoint. And I'm going to show you a very specific example. So not all rays point to the right. There are going to be some times that we're going to see a ray that goes like this, where the arrow is pointing to the left. Now, in this case, the correct way to name this ray would be starting with V because that's the end point, and then using the letter A as our second point. What a lot of students want to do, and what is incorrect, would be to just use the points in order from left to right. So incorrect here would be to say AV. And the reason that that's incorrect is because they didn't start with the endpoint. Now, the other shape we're going to talk about today is an angle. And the reason we're talking about rays and angles on the same day is because an angle is made up by looking at the space between 2 intersecting lines or rays. So we needed to know what a ray was so that we could see what happens when there's 2 of them. So I'm going to go ahead and draw a little angle here. An angle is made up of 2 rays that meet at an endpoint. And on an angle, you're often going to see several points. So I'm going to go ahead and label these A, M, and V again. Now the angle itself is the space in between. So in this picture, the angle would actually be this space that's in between there. It tells us kind of how much those rays have to turn in order to open up that wide. It's how many degrees are in between there. When we name an angle, there are a few different ways to do it. So option number 1 is to use 3 letters or points. When you do this, you have to imagine sort of tracing the angle. So you're going to start on one of the sides. You could start at A or V. And you're going to say a little angle symbol at the beginning for angle. And then you're going to start with one of the sides, A, and then M, because that would be the next point that you hit if you're kind of tracing this angle, and then V. Now you could also have started on the other side. So you could say that this could also be angle, start with V, and then M, and then A. The one thing you should notice here is that M is in the middle of both of those names because the second letter or the middle letter should always be the vertex, which is another word for the corner of the ray. So it's the corner of the angle. So the middle letter should always be the vertex. And then you should start on one side and kind of walk around and get to the other side. Option number 2 is you can just use the vertex. Now this is a sort of it sometimes works and it sometimes doesn't option. So if there was a picture where there was more than one angle attached to point M, we would not be able to use the vertex because then we wouldn't know which angle that was attached to that point we were talking about. However, in this case where there's only one angle at point M with the vertex at point M, I could just also call this angle M. The last option is sometimes you get lucky and in the picture when you look at it there's a little number like a 1 or a 2 or a 3 inside of the angle. So when that happens is that you can use the number to name the angle. So I could just call this angle 1. Now that only works if there is a number there. If there's no number, you cannot just draw your own number in. So that's sort of a sometimes it works and sometimes it doesn't depending on the diagram situation. Now, common mistakes that I often see are that students do not put the vertex in the middle. So for example, some students would want to name this angle MAV. But if I was to draw angle MAV, it would have to start at M, go towards A, and then go towards V. And so that would be a very different angle. So that's not okay. You can't start with the vertex. You have to put the vertex in the middle. Okay, now let's talk about some of the things that we have to be able to do. We need to be able to name rays and angles. So in problem number 1 here, we're going to name this ray as many ways as possible. Now this ray starts at endpoint B and it points to the left and goes towards T and S. So I know that all of my names should start with point B because that's the endpoint. So I'm going to call this B and then it goes towards T. And I would just draw a little ray over the top. Or I could call this ray where it starts with B and it goes towards S. And I would draw a little ray over the top. So that's just 2 different ways to name that ray. For this angle, I'm going to go ahead and name it as many ways as possible. Now, the first thing I'm going to do is look for how I might use 3 letters. So if I start with W, I could name this angle W. And then the vertex is always second, so I know that the vertex should always be the second letter, P, and then one of the letters on the other side would be R. Now I could also call this angle W, P, and then a letter over here would be M. So if you imagine kind of walking around, WPR or WPM. I could also start from the other end, so I could start from M, and I could call this angle M, and then P, and then W, which you'll notice is just the reverse of these letters. Or I could start from R, and I could call this angle R, and then P, and then W, which you'll notice is just the reverse of these letters. Now I could also, because there's only one angle in this picture, I could also call this by just using the vertex letter, so angle P. Or, because I got lucky here and there is a little number inside of this angle, I could call this angle 2. All right, we're going to go ahead and go to the next page of your notes, and we are going to talk about angle addition and subtraction. So, one of the things we often do with angles is measure them to see how many degrees are in the angle. If I was to name this angle, I would write angle A, B, C, or I could name this angle C, B, A. And again, you'll notice that the vertex is the second letter. However, if I want to talk about the size of the angle, so how big is this angle? I measured it and it's 40 degrees. Then what I'm going to need to do is I'm going to need to use a special symbol to show that I'm talking about the measure. So right before I draw my angle symbol, I'm going to write M for measure of angle, and then I'm going to say A, B, C. So the measure of angle ABC, where I name it like normal, would be 40 degrees. This little M right here is what tells me that it's the measure and not the picture that I'm talking about. I want to know how big it actually is, so measure it. As long as two angles are next to each other, like what we're seeing in this picture, we can actually add and subtract angles and combine them. So in this picture, there are really 3 angles. There's this little angle right here that goes from X to U to Y. There's this little angle right here that goes from Y to U to Z. And then there's this big angle that encompasses the whole thing that goes from X to U to Z. Now, what our postulate about angle addition says is that as long as angles are next to each other, so you can see that they're attached along this edge, as long as they're next to each other, we can add them up. And we can say that the measure of angle X, U, Y plus the measure of angle Y, U, Z would have to be equal to the measure of the entire angle altogether, which is the measure of angle X, U, Z. Now, here's what that means. It means that if I know that this angle is 70 degrees, and I know that this angle is 30 degrees, then I know that the whole thing would have to be 100 degrees because that would be 70 plus 30 added together. Okay, let's use that to write some statements about some pictures. So, if I was to give you problem number 1 and I said find the measure of angle XLV, my first piece of advice for you would be that I always like to highlight what I'm looking for in my diagram. So angle XLV would be this big angle here. Now that big angle, now that I've highlighted it, really stands out that it's made up of 2 smaller angles. So the first thing I'm going to do is write a sentence using geometric symbols to describe that relationship. So I'm going to be able to say that this first smaller angle, XLC, plus this big angle, this like other smaller but larger than the first one angle, has to equal the whole thing. So I'm going to say in geometric symbols, the measure of angle XLC plus the measure of angle CLV has to be equal to the measure of angle XLV. Now, if I now connect that to some of the numbers that I know because of the diagram that this first green angle is 39 degrees. Plus, I know because of the diagram that this blue angle is 103 degrees. And that's going to give me my total. which means my total for the measure of angle XLV is going to be 142 degrees because that's what I get when I add these two together. Now, let's go ahead and go over to the next page, and we're going to talk about something called an angle bisector. So the word bisect in geometry means to divide something exactly in half. So an angle bisector is a ray or a line or a segment that divides an angle exactly in half. So it's literally exactly in the middle. Because that creates two congruent angles, we can say that it creates angles that are the same size and they are congruent, and we can use tick marks to show that in a diagram. So the first thing we're going to do is practice using some symbols. So in this picture, ray KM, which is right here in the middle, so it starts at K, it goes towards M, is the angle bisector. So it divides this angle, the big angle, exactly in half of angle LKJ. Now, right away, I know that that creates two smaller and exactly the same size angles. So I'm going to use some markings to show that. So the tick marks that I'm going to use here are going to look like little arcs inside of the angle. I could draw one arc in each angle to show that they're the same size. I could draw two arcs in each angle to show that they're the same size. And I could also add tick marks on the arcs like this to show that they're the same size. There's lots of different ways to use tick marks to do this. Now, because of that, I can write a statement saying that these angles are congruent. So I can say that angle LKM, which is sort of this smaller angle, is congruent to angle MKJ because of the fact that we have an angle bisector. Now that's going to allow us to solve some problems. So if you go to the next page of your notes, we know here from number 1, if we read the instructions, that PT, which is this guy, ray PT, is the angle bisector of angle RPS, which is this big angle here. And again, I like to use highlighters and colors to show this. As soon as I see angle bisector, I know that I'm going to get two equally sized angles. So I'm going to go ahead and add some tick marks to my diagram just to show that in the diagram. Now the next question asks me to find the measure of angle TPS. Well, if I look on this diagram, TPS is the other half. I already know that this half is 37, so because it's divided exactly equally, I know that this half must also be 37. So I can say that this angle is 37 degrees. Now, RPS is the blue angle that I've already highlighted, which encompasses this entire thing. In order to find the size of that angle, I'm going to need to add these two angles together. So that means I'm going to get 37 plus 37, which is 74 degrees. In problem number 2 here, it says that ray PT, which is this ray right here, is the angle bisector of angle RPS. Now, because it's an angle bisector, I know that it creates two exactly equally sized angles. So I'm going to go ahead and use tick marks here to show that they're the same size. Now, this arc goes across both angles, so you'll notice that this entire thing is 75 degrees. That means that if I want to find the measure of angle RPT, so just this half, I need to divide that by 2. So that's going to give me 37.5 degrees here and 37.5 degrees here. So each of these smaller angles is going to be 37.5 degrees because that is what I get by doing 75 divided by 2. All right, thank you guys so much for watching. We will definitely talk more about this if you need extra help, and I will see you soon.